Okay, I appreciate everyone coming out, or not coming out, but joining us tonight. And we're always looking for more topics, and our topics are geared towards what people ask in the groups.io group and here. So if you have anything you're interested in, just let me know. And so with that, I'll let Landon take it away.
Okay, thanks, Dan. Dan, do you just want me to share my screen with my presentation?
Oh, sure.
Okay. Well, which one is it? Let's try that.
Okay, that got your, looks like your full screen or your window.
Okay, is that it? Can you see that?
We can only see the documents folder.
Oh, really?
You might have to stop sharing and then open it up and then try to share again with just the PowerPoint window.
Got it. Okay.
Okay, they got it.
Cool. I did this in portrait, so hopefully it's sizable enough that you can follow with the font. Dan asked me to present on, well, I don't know if Dan did. I forget who prompted on the email, but I obliged.
I did. It was Bill Neurbert.
Oh, Bill. Yeah, that's right. So I've gone through a couple different scopes and camera configurations, really in chase of high resolution, fast imagery. Given my visits to Danville are maybe once every 2 to 3 months. So I want to maximize the time that I have out there. That was kind of my original parameter set, and ending up with imagery that was able to be captured and still get me home and in bed at a reasonable hour. Kind of focused me on fast photography. And it's been kind of fun going through a couple of different equipment options that I've purchased and then sold over the past year or two. And the latest being into the Takahashi line. Back in, I think, October last year, you all might remember an image I shot out of the Lagoon and Trifid Nebula. Can you see that now? Or are you still stuck on my other slide?
Stuck on the first page.
Okay, we'll do. Okay, is it showing now?
Yes.
Yep.
Yes.
So this was shot with the Takahashi Epsilon 130, which is a lighter, more portable Epsilon version. Its f-stop is 3.3, so it's still relatively fast. And the focal length of 400, I think it's 400 millimeters, paired with the ASI camera I had at the time, which was the 2600 one-shot color, produced
fantastic image.
Yeah, it produced a pretty good field of view, and it allowed me to frame this object really well. I think I went through, and I've covered this in my presentation, and it's on the more technical side, just so you all can get a feel for the hurdles involved with a scope like this, and ultimately getting to what I would call a satisfactory setup that's actually fine-tuned and calibrated and collimated. I got the backspacing and collimation on this scope and camera setup pretty well set at that time. And when I go into the corners of the image, it's relatively coma free. So that image result was, I think, unexpected for me, and proved to me that the Takahashi scope was really worth the money they asked for it. With that, I knew I wanted to upgrade to the 6200 camera. Joe and I have talked on end about that camera, and Joe's got one in the mono version. And with that camera, the full frame sensor, it just seemed to me that it would pair better with the larger Takahashi Epsilon version, which is the 180 ED, the topic of our conversation tonight. So that was my kind of better, it was my only image result from the Epsilon 130 last year. And they gave me an opportunity to trade it in because the spider wasn't perfectly centered with the scope that they sent me. And, it was off enough for me that I thought, this isn't the standard of instrumentation that Takahashi is supposed to be delivering. And instead of me trying to funky around with the spider, I chose to take them up on an option to trade it in for the larger 180 scope without cost, just paying the difference to the larger scope. And so in the end, I think that got me to a slightly faster scope. And then one also, which I'll talk about at the end, if you guys want to know further about where I'm kind of heading with what I want to do, with a dual imaging rig, with a bigger scope, the 180 being something that I can piggyback my smaller camera lens setup with a little easier. So all those things combined led me to where I'm at with the configuration I'm sharing tonight. So I'll go back to the presentation. Dan asked me to lay out the specifications, which are put there on the front page. I've got a picture of the total setup that I'm running, shrunken down in the top right. And of note, because I know a lot of people in the group here have trended towards the CEM mounts. I did move to a CEM, I think a little over a year ago from a Celestron and never looked back. And it is part of the conversation that I'm going to speak to on slide number 1 about balancing. With the Newtonian design, I think one of the first hurdles that you've got, which is why I marked it as page 1, is balancing. For specifications, it's a heavier scope. So the scope itself is, once you put the dovetail bars on, you could call it about 25 pounds. So you do need a mount that can handle that weight, along with what I'd assume is another 5 pounds in gear, camera rotor, focuser, and guider. And then the other thing worth noting, and you guys know more about this than I do, but as far as resolution, the thing that Takahashi touts with the Epsilon is that the corrector, which I'll have to switch over the camera later, but I've got the corrector here. That corrector, they claim, is of such high quality glass that it produces a resolution to a CMOS chip that's considered and deemed higher in result than what you might find with like a standard Newtonian setup. And I think some of my image actually support that idea. So going to the first slide here on balancing. The first thing that you'll be challenged with is getting this Newtonian, what they call a fast Newtonian or a hyperbolic Newtonian, balanced correctly. You go through steps, and I've outlined them here just based on what I've learned to be my routine, where you first center the tube or the scope itself with the dovetail bar into the mount in a way that Dan, correct me if I'm wrong here, but I think it's where the deck is balanced when you've got the scope going like this. And then roughly set the RA balance with the counterweights on the shaft, and then bring it back to center. And then from there, you work to adjust the telescope in the tube rings itself to bring the telescope to balance in its resting deck position. So this is a balance issue created with the fact that you've got an imaging train that shoots off the side of the tube. And then if you choose to put a guiding system in the guiding mount, which is a little mount that's, I don't know, maybe like 3 inches down from the focusing area, it automatically puts you off centered. And you've got to turn the tube, you've got to rotate the tube within the rings such that when your deck clutch is disengaged, the scope doesn't fall left or right. And then you kind of reiterate that whole balancing process until you feel like you've got the rig fully balanced. You can see there that my, like where my dovetail bar is situated within the mount saddle. And you can also see where the tube itself rests within the rings to give you an idea of like where the balance point is with the camera up top, and then that offsetting the super heavy primary mirror on the tail end of the tube. So that introduces just another hurdle that I think, doesn't necessarily come with refractor scopes. And it can be a significant, practice in perfecting balance, as I've probably spent an hour messing with it at one point. The interesting note about this, and Dan and I corresponded about this last week, when you do rotate the tube within the rings, you create an effective rotation on your field of view. And this is worth the discussion on this slide, because it's, again, another hurdle with this Newtonian design. The camera chip, in order to get consistent spider effects in your image, where the spikes go either up or down, or in my case, I have them situated to go at 45s throughout the image. Your sensor should be square in a 0 or 90-degree position to the tube itself. So then when you turn the tube within the rings, you modify the effective field of view rotation. Dan and I plate solved one of my subframes, and it came out at, I think, 96.2 degrees. So you can see the effect of where I've rotated the tube, and you can't really tell from this image, but the camera is slightly shifted away from the camera point here, such to kind of counterbalance the guiding weight of that little scope right there. So that's something to keep in mind. And when I first had this out, I was using plate solving inputs on sequence generator that were from Stellarium based on like a 90-degree standard rotation. And it kept, every time it would plate solve, I'm like, no, that's not what I thought I was shooting, or that's not the field of view I thought I was getting based on what I had in Stellarium. So it's important when you've got this set up to calculate your effective rotation, and then in your pre-framing process, whatever software you're using, that you input your camera chip as rotated equivalently. That way you're actually seeing in the planning stage of your imaging process, like what you'll actually get when you get out there and take your first subframe or start plate solving for your location. So I thought that was an interesting point to make, just something to be aware of with this sort of setup.
So you're not rotating the tube while you're doing your between your images.
No, I think it's important to get to a point with this setup, and you'll see that theme throughout this, that once you set it, you forget about it. And, getting everything right is important for ultimately getting the result that you want when you're in the field. So where you set, while you're at home, you do all your balance work,
Okay.
Make sure you remember, you put kind of some memory points with where you've got your counterbalance, where you've got your scope within the saddle of the mount itself, but you've already set your tube rotation within the rings. and you lock it down once you do it and you get it to a balance point. And the other thing worth mentioning, why I brought up the CEM to begin with, is that the RA shaft is able to be balanced. There's 2 set screws in the top of the shaft ring. And when you loosen them, you can kind of, move the RA shaft into a position that offsets any misbalance at the top of the, at the top of the scope. And so that's why I made that note at the bottom that even when I think I've got it perfectly balanced by rotating the tube within the rings, there's still a slight offset. And I can't explain this stuff. I just know that it, you know when you're balanced because the thing doesn't move, right? So until you get to that point, you're not happy. And when you do, you're happy. And with the CEM 60, you've got the ability to rotate the RA shaft and set it at a point that perfectly counterbalances your whole setup.
So when you're doing this rotation occurs between sessions is it will cause you a problem?
No, I'm talking about the first, when you unbox this thing, something that you've got to go through. This is assumedly you do this once and you don't do it again, unless you're changing your equipment configuration.
All right. Because then what that lets you do is once you get it where you want, you just mark some witness marks on there, and then you can verify things are correct once you get everything set up in the field, right?
You got it.
Yeah. Okay.
So like I my 6200 camera a couple weeks ago, and because of the weight of that camera compared to the 2600 that I had on there, it necessitated a rebalancing. So, anytime you change the equipment on it, I think you're going to be moved to kind of go through the same process.
And then the mount can't handle slight imbalances. Why is balance?
I think, Grant, you and I talked about this when we were out there a couple months ago, but I think my primary goal is to get to relief of as many variables that will ultimately impinge my result. So
right, and I wanted to come back. I wanted to circle back with you on that because I wasn't thinking that right. If you have a gross imbalance, that can cause some dynamic things with wind. But if you're off just a little bit, and you were really thinking that was a balance is a highly critical thing, and I wasn't sure how much how critical that really is within some some particular margin. And that's why I was kind of wondering if the group has issues with very subtle differences in balance. And I guess the answer to that is crickets. Okay, sorry, Landon.
Well, I don't personally on my old one. I balanced it on my old EQ6. I balanced it once, and I just kind of throw this stuff on. But I mean, some you do, some you don't.
What is the imbalance affecting? Is it causing what, drive errors?
Yeah, it would impact tracking.
Okay, all right.
yeah.
So,
I've got, you'll see my preferred guiding result when I get to that page, but I try to get to a guiding that's super minuscule, and in my mind just gives me peace of mind that I've eliminated guiding as a variable result.
That's exactly what I was thinking. Most of these tools have got a guiding graph, and that's what I would probably be doing myself, is finding out how much imbalance causes what kind of tracking error. All right, thank you.
Yeah. So the next general hurdle that you'll face with the scope is getting to an acceptable collimation. One of the images that I've included on the back page at the end of this is the first image I shot with the scope. And I know for a fact that my collimation was off and the result was still what I would deem acceptable. So I think generally, and Takahashi backs this up, as long as you're like reasonably well collimated, you'll be happy with your result. but to the degree you can control how well that you collimate, I think it's worthwhile understanding, learning, and going through the appropriate collimation process. It is a learning process. I spent probably an hour and a half on it before I really felt like I understood the mechanics of how the scope collimates. And primarily, the primary has a push-pull system with a locking nut on it that is super complicated or confusing at first glance. And you don't actually understand how it's working until you get in there and mess with it, throw it off enough that you've really got to fight your way back to it. And so after, an hour and a half of messing with the primary adjustment, I finally figured out how it functions and then what it was going to take to get the primary situated where I would never have to touch it again. The secondary is meant to be able to be collimated with super fine tuning once you get out on site. If you go out and your car rides an hour and, somehow something got nudged off, it's meant to be that the secondary can be adjusted to bring you back into collimation, and just with a quick check of the collimation eyepiece. I've done this and never really had to recollimate once I've gotten out there, which means my shocks on my car are still functioning properly. The first image there on the left is what the collimation looked like for me out of the box. You can't really tell, but it was slightly off-centered, and that is acceptable. It really didn't need any adjustment. And you can tell from the concentric nature of the shot right there, it's pretty well collimated. So when Takahashi says that they deliver a scope that's collimated, at least in my case, it was. Shown on the right is the collimation hardware that comes with this scope. They provide a fish line that you have to cut in half and then lay across the 2 notches on each axis, as you can see how it's laid out. And then you've got to tape them down. And that has some inherent flaw to it because the stretch of the line is only as good as the adhesive on the tape is. So I chose to kind of I taped it once and then looped it back and taped it twice just to hold it in. But having a really taut X on that piece, I think, is important because anything else will just send you hunting for something that isn't real. So step one, and I learned this lesson too, which is a note down there, that the recommendation on collimating the scope is to do it pointed up. And it makes sense because if there's any loose item between the primary and secondary, it's gonna affect you least while you're actually shooting, which you're going to be doing pointing up at the sky most of the time, right? So the first time I collimated, I pointed down. And I also found that because I didn't know how the primary push and pull and locking mechanism worked fully, that I had a little slack in my primary that by the time that I pointed my scope from down to up, the concentric rings had moved slightly off, indicating that my collimation wasn't good when pointing up. However, I shot an image after that collimation that I was happy with. So again, I think everything's relative here. If you get it reasonably collimated, you're going to be happy with the results. So you set it to point up, you get the collimating piece assembled, which is technically 3 different pieces there. And it's basically a Cheshire. And you first adjust the secondary. And in the best case scenario, the secondary dot is already centered. If not, you've got to fully loosen the knobs and then rotate it until you get that dot centered to the Cheshire line of sight. And then you bring the secondary ring into center, lock that down. Then you go to the primary while it's pointed up and adjust the primary until the primary disc is concentric. And then to the degree that the primary adjustment then throws off the secondary adjustment, you reiterate it until you're within a reasonable, collimation standard. you're happy with. Trying to see some of the other notes I made here. The secondary adjustments, everything is super smooth, and I'll compare this to my Orion 8-inch Newtonian scope. It's night and day. The build quality of this scope is unbelievable compared to off-the-shelf products like Orion. And I went down many rabbit holes with the Orion, trying to figure out how to get the spider veins parallel so that my star spike patterns weren't divergent, etc. In this case, with the 180, the spider came perfectly centered, and the collimation out of the box was pretty spot on. And the ability to get the scope collimated after you've done certain things, which I'm about to jump into, another hurdle with the scope, is generally smooth and accomplishable. So as far as build quality and the scope itself, I think it was $4,800 for this scope, but as far as image result, I can check that box. And as far as navigating the collimation process and being able to modify my hardware configuration, I can check that box pretty easily too. I made a note there about the primary being complicated. I think you just gotta go through the learning curve and figure it out. But once you do, you understand how it works, and it's actually pretty easy once you know it to get the thing collimated. And I noted here that I was chasing a looseness in the primary. I finally did fix this because what I really needed was a thin wrench. It's a 17 millimeter nut on the primary. And as opposed to the wrenches I have in my normal toolbox that I think are a quarter thick, I actually found some that were like a 16th set thick that I could get in there and actually adjust the thing properly. So that speaks to collimation. I chose not to go the path of adding a moonlight. I had done that with my Orion Newtonian, which is expensive relatively. I think I paid $850 to $900 for my moonlight rotator on the Orion, which was more than what the scope itself cost me. I think I paid $500 for the scope. And so in this case with ZWO's electronic autofocuser, as long as you're careful with the one single screw point that the stock focuser offers as a mounting option, you can see it kind of, if you can see my mouse, it's right there. I don't know if you guys can see my mouse or not, but I'm highlighting the screw point right there. And I had to put a couple little small spacers in there to get it offset right within the limits of what the EAF mounting system allows. But that one screw point combined with the connection to the focusing axis right there from the EAF motor is all that's required to get a firm rotating grip on that configuration. The EAF I think is $200, so it's pretty affordable. And its step count, or its step, I don't know what you call it, but the degree of the step is fine enough to handle getting really nice focusing on this scope. There is a aftermarket Takahashi option to add a micro focuser on this, which you can also adapt with an electronic autofocuser. I'm not sure if you could do it in the configuration that I'm showing here, but they sell that as a way, kind of like a feather touch option. But in this case, because the step on the EAF is fine enough that I think I use a 20 step count beyond my focus point, or for my focus point settings for building my U-curve. It gets to a really nice focus point just with this $200, add-on. For installing it, I showed you the actual screw point. These are the steps to actually install the thing. And one thing to note is that you've got to drive the stock focuser down to 0 when you first put in the set points or the set screws between the EAF and then between the axis of the stock focuser, or the rod or the cylinder. And then at that point, when you log onto your, in my case, through Sequence Generator Pro, if I activate the EAF module, the option setting, it automatically pulls up the options, I think, that are native to the EAF through the ZWO software. And it gives you a one-click button option just to set the 0 point. So there's no risk, as long as you do it that way, there's no risk that you'll drive the focuser to the 0 point and cause damage to the EAF or your set screw points. So I think that covers that. And then also one thing to be wary of is there is a locking screw, as with most focusers, that you've got to make sure is disengaged. And with the Takahashi, it's not like my Orion, where the locking screw, theoretically, if you jiggled it around enough, it might like find its way to tighten itself. This thing is pretty, again, well made, like everything else on the scope. Almost feels like it's fully lubricated inside, that it'll just do what you want it to do, and it sticks where you put it. So just make sure that's disengaged so that your rotating process or your focusing process can function as your software guides it.
Hey, Landon,
Yep.
on your EAF, did you set a backlash?
I do have a backlash, and I have two EAFs, and I've noticed this on both. Out of the box, the EAF has 0 give. After you use it for a couple sessions, it will build give, such that setting a backlash in there is going to be necessary. Additionally, there's, with the set screw adapter there between the EAF, I am probably not using the right word, but the axis or the axle that comes out of there and to the manual focusing piece, like that has a little spring to it. So having backlash set is definitely essential for achieving prime focus. I think my backlash is set at like 200 steps just to be super safe. I think my technical what am I saying here? Steve, give me the right term.
I'm still not with you.
The
Backlash?
backlash. Sorry.
Oh, okay.
The backlash. I think my actual backlash is something like 50 to 75 steps. So
Okay.
yeah, I've got it set at 200 just to make sure it fully catches every looseness in there.
Okay. I've seen where you can actually measure your backlash by going in and stepping it like by tens, and noticing when your focus wheel on the other side first starts to move.
Yeah. So does it? I guess you do that manually.
Yeah, manually, in the sense you're clicking the button to step your focuser.
That totally makes sense. Yeah. Yeah, I'll do that sometime just to see what my actual backlash is.
I'm
So
muting.
I might be overcompensating at 200 steps. Okay, so that's the EAF. The next trick to the scope is the big one, which is backspacing your camera sensor. As your optics get faster, your margin of error gets tighter. I think Takahashi generally, they claim that you can be within 0.5 millimeter and survive any mismatch in backspacing. But there's a couple interesting points here to highlight. If you go on cloudy nights, or if you call Takahashi and get the wrong guy, they will tell you that the backspacing point is 56 millimeters. If you bring up the technical page, it is 56.2. And that's not, that's not a big difference. And then if you erroneously apply traditional backspacing standards, you might think that you're going to use 55, right? I think in my experience with fast optics, just because I dealt with this with my Samsung lens or Samyang lens, and it's at f2, like I went through a test with that lens where I tested every 0.2 millimeters change with those super small ZWO, like, I don't know, paper type spacers. And I ran 10 different test images and then visually graded which was the best one. And that's how I set the back focus on my lens. And I think that was important in that case because the build quality, you know, it was Chinese made, high production type stuff. In this case, I've had the backspacing anywhere from, I think, 55.7, the first image I shot it at. I think it was actually less than that, out to the 56.2, which I think I was out at in the last image I shot. I've revised that now lately since I got the new 6200 camera. But I think importantly, I purchased this digital steel caliper to make sure that I could measure each 1/10 of a millimeter. The caliper set that I had before that really was not that accurate. And it was not a digital meter, it was a manual. And so I think when you're dealing in these like super tight tolerances, it's important to get something that's high precision. So I made a note of that in step 2. But in step 1, I give the calculations for what, you know, backspacing I needed to achieve in the spacing itself based on what I actually had. So the Takahashi corrector is the back plate of that is the 0 point. And then your camera sensor is the 56.2. There's 17.5 millimeters of built-in backspacing on the ZWO one-shot color cameras, which is what I'm using, which yields a target inside to inside from a component perspective, and then outside to outside from an actual spacer perspective, target of 38.7 millimeters. So you can barely see it in the little photo that I've got there, but that backspacing configuration, which included an adjustable M48, got me exactly to 38.7. I think it says 7.0. If it's 6.9 or 7.1, I don't think that matters. Yeah, so I got there with the high precision caliper, and I'll switch over here real quick because I think you guys will enjoy seeing this. So I got to stop the share. Okay, so this is my current camera. And if you watch my finger here, so this is the Takahashi corrector. It's the high quality glass that is the same thing as a coma corrector on a Newtonian. This in here is the spacing that gets me to that 38.7. And this is the new ASI 6200 one-shot color. And so, you know, hopefully you can see down there the full frame camera chip. And what I've purchased since to help with this, this process of getting the correct backspacing, and you can barely see it here, but it's if I get it to the camera close enough, you can see that stainless steel spacing ring there. This is, and they should probably pay me for product announcement here, but I found a fine tuning spacer set on a Gina Astro. I think that's what the website's called. And the brand name is called Blue Fireball. And they sell a set of stainless steel spacing rings. I've got the full array of them here, minus the one that's actually in my spacing setup right now. But these, I think, are my latest like ease of access to getting to the ultimate backspacing. And they start at 0.1 and they go out all the way to 1 millimeter in 1/10 of a millimeter increments. So when you're dealing with high or low tolerance backspacing requirements, I think it's important to look into stuff like this to help you not go crazy and lose your mind over trying to hit the right backspacing.
Hey, Landon, this is Mike.
Yeah.
Hey, on those spacers, did you have issues with the quality of them? Because I bought those same spacers and they are not smooth on the edges, which causes problems when you're talking about 0.1 millimeters.
I did notice on the 0.1 millimeter spacer that you're right, it's got some possible inconsistencies with the spacing, but specific to the 0.1 through 0.2 millimeters, they actually stamp the name and the spacing width. I don't know if you can see it there.
Yeah.
Yeah, they actually use a stamp. And so it causes a protrusion on the other side. So I just avoided using those, Mike, because I did see that as an issue.
Yeah, mine must have been a bad batch because it had like burrs and all this kind of stuff on it. They just were not made right.
Yep. Yeah, and I forget how much they are. I think they were like $30. Does that sound right?
Well, and Blue Fireball isn't high-end product. You know, it's a Gina Astros kind of in shop
Brand
kind of, we made this in China cheap.
Stamped it on the cert.
I have a lot of Blue Fireball stuff.
Steve, well, it's, I think, Mike, to answer your question, at the end of the day, if that micrometer reads 38.7, I'm happy,
Yeah. It's definitely better than the pieces of paper that Ryan and I put together for mine. So I'll definitely be switching them out. I just did a fine wet sandpaper on
Oh,
it
yeah.
to get all those burrs off.
The problem is if they're wedged, if they're a wedge, that could really.
Yeah, like it'll cause tilt.
Yeah.
Yeah, you're spot on. So what I did lately, and you guys probably saw it here, I'll do it again. If you look through the corrector here and into the camera chip, you can see that if like you look straight down the edge, the top corners of the chip are cut off. This is M48 spacing. So I think, and Dan will harass me about this all day long. I tested an M42 setup, which was bound to create vignetting. It did, in my opinion, based on my flats. And then I did a flat based on the M42 and it looked a little better, but there's still a fall off point. And I think, Dan, you're right that it's probably native to the Takahashi, but out of an abundance of caution, I ordered through that custom parts site an M54 spacer that was spot on to my need. So I do have that coming within the next month. That'll hopefully take care of the whole spacing issue and me having to, every time I disassemble it, having to recheck the measurement. And I think that was like $110 shipped, and it's about a 6-week lead time. So the last item of note on this page, this is another quote hurdle, and you guys have heard me use that term because there are many of them when you're dealing with this equipment. When you change your spacing, you will change the camera chip rotation once you've actually screwed the assembly into the mount. The focuser side is a female, I don't actually know what it is, but it's what the corrector male screws into. And so when it seats, based on your fixed spacing and what you threaded in as a fixed spacer, it will dictate how your chip is rotated to the scope, which then necessitates using the actual rotator on the scope itself. If you go back to the picture of the focuser, you can see an aluminum ring at the base of the rotator, and it's got these 4 straight nubs coming off of it that, if you force counterclockwise, will loosen the rotator. I will note it. again, it's high quality, so it feels very sturdy, and it rotates very smoothly and doesn't really shift out of its position. But you use that to then square your camera chip to the point that you want it in respect to your spider vane effects. And I can't remember, Michael, if it was you or Ryan or somebody else who warned me that if if you rotate your camera chip in a way that your spider vanes are not at some like normal rotation angle, that if you go to do a mosaic, it can make things really complicated. Bill, I don't know if you've had experience with that with your Newtonian, but is that the case?
Yeah, I mean, it's super sensitive to alignment. And, I think everyone knows the depth of focus goes up as the square of the F number, and the aberrations go up as usually the cube of the F number. So, everything you're talking about on alignment and getting the tilt in, and it gets harder and harder as the F numbers go down to lower and lower numbers. It's amazing what you were able to achieve.
I'll take that as a compliment, I guess. It's an important point here, because I think this is like one of those, read it before you buy it things. When you do change the rotation on this scope, you have to recollimate.
My scope isn't as of high a quality as yours, but I completely agree with what you're saying. I've experienced, putting my, first of all, if I collimate off my focuser, I'll start to get one collimation. Then I put in my corrector, coma corrector, and realign. Okay, well, that's not quite the same, because that barrel has a different offset to its axis, so you got to align that. And if you rotate it, it's a good idea to check it, yet again. So yeah, I've got into the practice that I collimate with my corrector in place, and I keep it in a fixed rotation so it doesn't shift, and then things work all right.
All right, so that backs up what I'm saying here. I have tried to get the collimation to a point that, you would think that if you've got a great collimation result, everything is centered, component to component. But for whatever reason, every time I change that rotation, that collimation changes too, and I have to recollimate. So I've got it there on step 7, bolded, recollimate after you change the rotation. It sucks.
Yeah, I agree with that.
And that'll lend to some final remarks I'm going to have on the scope, which is that it's probably more geared towards like a permanent setup scenario. Next is polar alignment. This isn't too much related to the scope itself, but I know, like Grant, you were asking about the iPolar process when you were out there the other night with me.
Yeah,
it is a lot easier than the QHY product. And so I've just given an example of what the program screenshot looks like. In my case, I got the CEM60 that had the iPolar built in. So it's tucked away real nice within the polar tube. And it is super quick. One comment I've made about the CEM60 here, and I think, Don, didn't you get a CEM lately? I think Don got like a CEM70, right?
Well, I actually don't have it yet.
Oh, okay, you're still waiting on it.
Yeah, I actually probably mistakenly, but I have to make these decisions. I got the actual mount. I never got the tri-pier, and I started playing with the ASI Air Pro. And I said, you know what? I don't want to rely on the ASI Air Pro, so I want to be able to go to the full mount, to be able to do this. And the more I thought about it, I said, you know what? I'm going to go and do the guided version, even though I don't care about the guided version. I wanted the 3.0 USB, and I wanted the Wi-Fi, which I like because of just the way I like to use it sometimes. So I don't have it yet. I'm about 3 weeks away.
Nice. Okay.
God, another 3 weeks of weather. Oh, jeez.
Well, I was
Yeah.
gonna say, I mean, I got the full frame ZWO camera, so you all are screwed for the next month anyways.
Yeah.
Okay, so the thing about the mount that I was going to mention, I've had no problem with my mount handling this weight with the scope. The CEM60, I think all in, I'm probably 30 pounds, maybe less. And I've had an approach lately that I've used when I go out to Danville, where the set screws on the mount itself, after I've adjusted eye polar, instead of like loosening the adjustment nuts, I guess is what they're called, all the way and then setting eye polar, I'll loosen or I'll tighten down the adjusting nuts and then back them off maybe a half a turn to keep it, still somewhat tight, and then go through the eye polar alignment process and then never actually lock the nuts down. And for some, it holds through the night. And the weight of the scope isn't affecting it, but for some reason, at least on my mount, like the lockdown nuts, if I take them down tighter, it'll throw my, you can see the big red dot is your celestial pole. It'll throw that out of the crosshairs enough that's not, quote, perfection. So, and then the other thing about eye polar is that, and I cannot explain this yet, maybe I just need to keep recalibrating it until I get it right. But like when it's pointing straight up, the red dot will be out of the crosshairs. And I'm not sure that actually means that you're not, polar aligned, because I still get great guiding results. But that's one finicky thing about eye polar that's kind of left me scratching lately. And then the guiding itself, this is, I think I took the shot for Ryan one night that I was out there, but I've blown up the actual error that I had that night. This is a good depiction of what I like to get my guiding to look like and what it usually looks like. I've had a couple directions that I've pointed that haven't been this great, but my preferred guiding result is like 2/3 of a pixel error as shown there, which is usually pretty achievable. I've been using a medium dither, which I've found, I think, has given me a stronger stacking result. And when I'm out there, I try to get 2 hours of 5-minute exposures in. And so I think at that subframe count with medium dithering, I've been getting good noise reduction.
I'm sorry, are you off axis guiding?
Okay, what do you mean by that?
Are you guiding through the scope?
Oh,
or do you
no,
have a
yeah. Sorry, Bill.
Yeah. So yeah, my experience is the same. I find that the lowest dithering setting just doesn't give me enough rejection, and I end up getting smearing. Sometimes it makes it worse sometimes in the stacking. But if I go to medium, then it has good pixel rejection.
Okay, so that backs that up. I think, yeah, I don't know when I haven't logged this or anything, but for some reason I think I've had medium dithering set lately, and I've been really happy with the end result, from a noise reduction perspective. And then I know there's a big debate over gain out there. I run all my imaging at 0 gain. I don't, I think these cameras have gain allowance, but I just don't mess with it. I think Don and I were out there one night and I thought about amping the game all the way up. And then I was like, I don't want to shoot darks again and all that stuff. This is my flat. This is what it looks like to shoot flats with the scope. And I just use a white t-shirt and then the Spica flat panel. And then lately, I've been trying to do this right before dark, just so I can pack up and get out of there quick at Danville. But with that, whenever you do it, I think the most important thing to note about flat shooting with such a fast scope setup is that you need to be as close to the focus point that you shot with as possible when shooting your flats. When I had the Newtonian, I had some issues once, and same with my Ritchie Crutchin, which was my first scope, where I shot flats like way away from the focus point. You could tell. So that's one kind of checkbox item I try to stick to, which is to make sure that before I shoot flats, if I'm doing them first, that I run a pretty good focus routine, and then shoot flats right after, and knowing that my focus point has not changed right after my imaging is done. And then I think my last page is just the two images that I've shot. The first one, my backspacing was a full 1 millimeter off of the target backspacing. And I didn't realize that until after I'd shot that Iris Nebula shot. So it's a little less resolved, but I felt like I had pretty good backspacing on the M45 shot there, and was pretty, very happy with that shot. So two blue objects so far, and I'm hoping to get out there for another kind of cool target soon.
That Iris shot, was that when I was out there with you?
Yes.
Yeah.
Hey, Landon, thanks for going through all this. I have to admit, I was really inspired when you got that scope, because, again, we know that the focus criticality goes up as the square of the F number, or as it goes down. So going from F8 to F4 makes it 4 times harder, and aberrations go up as the cube sometimes. And I've always really shied away from being faster than F5, just because my previous junkie scopes couldn't make it. But after seeing some of your shots, I was inspired to go down to F 3.7, and I'm really excited about imaging at that speed. So thanks for pushing me over the edge a little bit.
No problem. But Bill, I mean, you've gotten one of my themes here, which is that I try to be technically accurate with these. I think hopefully that categorizes the steps to getting your equipment ready for shooting. And I try to be as technically accurate and aware as possible, so that, if something ever goes wrong, the first thing you think of, especially when you're in the field, is what the hell did I do wrong, right? And at least if you're aware of everything that's involved, you can hopefully eliminate as many variables as possible towards,
Oh yeah, you had a really methodical approach when, you were talking about how you were, taking images and varying the backspacing, and that's a lot of work, but it pays off in the end, as you can see in your images. I just don't know how you get there any other way.
I think that's right.
Well, Bill, you don't, unless you get lucky.
Yeah, I'm not very lucky.
Me either.
It just drives me nuts, as Landon kind of, I think, hinted at. You get out in the field, it's cold, it's dark, you want to get images, and then you see, oh crud, I got a big, blurry star in the corner. What's going on? And it can just ruin a night.
Well, let me ask you guys this. You don't necessarily have to do all this prep work, all of this alignment, all of this changing in and out of filters. You don't have to do that in dark skies. You can do that from suburbia, can't you? Because you're just looking for, basically, its stars are going to give you your critical focus, right? And your alignment.
Yeah, it's kind of true. I mean, dark skies are so much more forgiving than light polluted skies, and I'm in like borderline white. So
you mean they're forgiving for the testing that you have to do in order to get things optimized?
no, I think the result. I mean, like when I went through that procedure on like putting 1/10 of millimeter spacers in, I did that at home. So you're right, Grant. You can do that stuff at home, but at the same time, shit, like, that was visual determination of what graded out best. Like that was not, PixInsight didn't tell me which spacing setting to use. And so with that, like, seeing what the highest quality subframe result was not easy in a light polluted setting. Right. And I think the point is, like, I guess my point is, I know my backspacing was wrong and it was beyond the tolerance that Takahashi said is acceptable in that image of the iris, the night that you and I were out there.
Yeah.
But it still looks like a good image. And I think it looks good because the dark, Danville's got really good skies.
Well, sure. I mean, what I'm getting at is I think your first and second order alignments, getting your balance, getting at least in the right ballpark as far as your spacer is concerned. You don't necessarily have to make a lot of trips out to dark skies to do those initial first, second, and third order configuration and calibration steps.
Oh, you got it. No, Grant, you're spot on. You do all of that stuff at home.
Right. Okay.
Yeah.
And because I was kind of getting this feeling that was, man, all this stuff has to be done out in dark skies at like Danville. I'm like,
No, sorry. I should have noted that at the beginning. This is all like prep work to get your equipment ready to travel.
Because then by the time you get out to Danville, you're well within a ballpark and you got your witness marks down, so that you're not having to figure out where your balance is a very fine balance at Danville.
Exactly. Yep.
Okay.
Exactly.
And then when you start taking your subs, then you can see if you have to add or subtract a 0.5 millimeter filter instead of going to hole 4 or 5, right? Yeah.
Yep.
I think the other thing that, I kind of really agree with Landon on is, as you get to these faster and faster scopes, the alignment is more and more critical, which means flexure is also more and more of a problem. If I have a history of buying kind of junky scopes, the couple I've bought more recently are higher quality and more rigid, and that's so important in these fast scopes. And I would think, Landon, you're finding that the build quality is probably really important for you to hold that alignment, not just in transportation, but as it's pivoting around the sky so that it's not flexing.
You have summarized my presentation. I think, the ask on the Takahashi is really focused on, is it as high quality as they say it is? And I think my conclusion is yes. The only other topic out of here that I didn't explicitly cover in the presentation that I imagine some of you might want to think through or have thought through in already is, I guess here's my perspective. I am scared to use a mono camera with this fast setup. And I say that based on experience with my f2 Rokinon lens or Samyang, whatever the hell that brand is. I had the 1600 with filters, and the backspacing was theoretically different with each filter. It was so frustrating. And you could tell, like, when you set it to luminance, when you set it to red, green, and blue, they say they're supposed to be parafocal, but in my experience, it wasn't. And I think when you get into these, low tolerance, fast, high, high precision equipment setups, I guess maybe you call me the guinea pig, but like this one-shot camera setup, the latest, the latest chips is really working well for me. And I would be scared to try a mono with filter setup on this scope for, fear of any complications of variances in, focal point as you go through the filters at f2.8.
Hey, Landon, you gave me my heart arrhythmia came back thinking about, okay, so I go through this whole thing to get all these alignments right, and then I'm going to start switching filters in and out. Yeah, you just added, for every filter, you added at least half of the steps that you went through to get,
It's
my
so
heart kind of skipped a bunch of beats there when you mentioned going with monochrome. And
yeah, I only say this based on my experience with the f2 lens. I couldn't solve it. I spent hours dealing with how to get to good flat images between filters, and it just didn't happen for me. So, like, I know Joe's Joe's going with some filters, and he's got a totally different setup than the Takahashi here. So I think it'll be more forgiving. But you know, those are my latest thoughts, and why and Joe and I talked about this a couple of weeks ago. I decided just, you know, if I'm going to be going out to Danville and I've got a 2-hour block of sequencing that I've scheduled, you know, if the least amount of variables that I can input there, the better. And I think I've just been happy with the one-shot color results here, you know?
I think with your setup too, with the one-shot color camera, I mean, you're not going to be going out to Danville when the moon is up and things like that too. So you don't have the other half of the time when the moon's up and you want to use the narrowband filters. That's not necessarily an option because no one tends to go out there when the moon is up. So I think that's another thing too. But as far as you know, with the fast systems, that's where it gets crazy. If your filter wheel, the ASI filter wheels, the QHY filter wheels, you know, they're so, and filters move around in those. And you know, when you're talking about, you know, 1/10 of a millimeter, I mean, the filter could move that far, you know, just flipping between luminance and the next one.
Yeah.
And so, yeah.
Thank you, Dan. I didn't even want to try to enumerate all of the issues that are added with something like that. My experience with you guys out there with the C14 and that setup for the Mars thing was like,
yeah, there's a lot of, with the slower scopes, you know, f4 and higher. I mean, there's a lot of tolerances, but once you get below that, I mean, it's a handful of microns between being in focus and being way out. And with filters, it would be a challenge. There's actually a guy in the observatory next to me that has a official Stellalari, I believe. It's an Italian scope.
Yeah.
It's an f8 or f2.8. I think it's about a 14 or 16-inch scope. Yeah, it's literally a $50,000 scope before you get options. And he's been trying to make it work for over a year now and still doesn't have anything out of it that he's overly happy with.
if he's got money for that scope, he might as well just pay a few more bucks to build a little small shack out there where he can.
Well, yeah, it's in a remote observatory, and he's had people down, flown in, and it just, I don't know, when you're talking about those really fast scopes, it's just beyond complicated. I mean, Landon's trying to stress how hard it is, and it's harder than that. There's a lot of reason why there's a lot of people like me that use slow scopes, because, you know, like flats and things like that, I can take my flats when it's 110 out, and those work when it's 2 degrees out. You know, and with his scope,
that would not be the case with me, Dan.
Yeah, his flats taken at the start of the night, you know, in New Mexico, when the temperature drops 30 or 40 degrees, they might not work for those images at the end of the night.
Thank you, Dan, because I wanted to ask Landon about the temperature changes and the effect on his rig.
Okay, so I have 24. This is what I've been up to lately. I have 24 planned subframes, 5 minutes each. I will, at my discretion, jump in at about number 8 or 9 and refocus. I notice a 15 to 20 step count change. And then again, just out of an abundance of caution at subframe like 16 or 17, I'll jump in and do I'll pause the sequence and refocus. And there may again be a 15 to 20 step count change. Okay. Is that enough to change the image statistics? It has not been. But if the theory is you want to make sure that your focus is on, I've just been doing it, you know, out of an abundance of caution.
Why not? The question is, so you are seeing a change in focus with temperature. What about a change in collimation alignment? And by that I mean like tilt. Are you seeing any effects on one side or another of your subframe?
I've not really looked for that. I just wake up the next morning, run the automated stacking through PixInsight, and then or the batch processing module, and then
What's your lowest temperature been that you?
I think maybe it would have been the other month, and I think we didn't even go below freezing then, maybe 40 degrees.
So from start to finish, you're talking about maybe a 30-degree, differential, delta between.
Yeah, I think that's right. Dan, does that sound right? 20 to 30 degrees.
I wouldn't think you'd see that much in the 2 or 3 hours you're shooting, maybe over a whole night, but
Okay.
most of his runs are much shorter.
Okay.
But I would think 15 steps on the ASI, that could be like 1,000 on the Moonlight. So it's a pretty big change, and being that you're not really seeing a whole lot, that's probably a good thing, but it's still a fairly big change.
Yeah, but like I have the FHR and the star count data set to track and sequence generator, so it updates every subframe, and they're really, even when I refocus it, there's not a big difference in that data. I don't know if that's the right data to be looking at or not.
Yeah, one of the other things too is that the I don't know how to say it. The wider field, you're not going to see as much of a change in that.
Yep.
So that's on the helpful side for you.
Yep. Well, that's my final comment, is that, Dan summarized my setup at, what'd you say, Dan? Think super fast, super wide field.
Yeah.
And that's another, positive or thing in the corner of just sticking with a one-shot color, is the images that are in front of you are with the ASI 2600 one-shot color, which is 26 megapixels. And the new ASI 6200, I think, is something like 60 megapixels, maybe a little more. So, as far as the resolution output from this scope, I think it drives the need for filters kind of out of, it just kind of makes them irrelevant, because the end resolution that I'm getting here is just, it's going to be massive,
One other thing about such a fast system is the narrow band, like an HA filter or an O3 filter can really be a problem with these systems, because the light path through the filter is so different from the edge of the mirror to the center. I know they sell some fast F number narrow band filters, but they're really pricey. So, that's a good point, Landon, that these super fast wide field systems are probably better suited for a one-shot color. I hadn't really thought about that.
Yeah, so I've had the Beta high speeds, which I used with the RASA that I had. I don't know if you guys remember, but I tested the RASA 8-inch, and it had a whole set of problems of its own. And it really, build quality, like it did not compare to the Takahashi here. So those Beta high speeds did work with the RASA, which I was using from home, and I have a North America nebula image that I shot with that is super crisp out of the Beta or high speeds. So I think they do work, and they probably would work if you got this thing collimated right. Collimated right. Again, I worry about the focus point differential per filter at this speed. So, and plus, you guys can probably tell I'm not a narrowband guy. I really like this pure color stuff.
So Landon, it's Ryan.
Go ahead.
Yep.
Great presentation. Your work and perseverance and attention to detail has made a huge difference. And I remember your first images, when we started working on some things together, and Wow. Well, the stuff you're producing now is really incredible.
So are you saying my equipment search has been successful at the end of the day here?
Well, it's not just the equipment search, but then all of the things, everything you laid out here to get the equipment dialed in the way that you want it to be.
Exactly.
You've done an excellent job. It is a great presentation. Really enjoyed it. I do have a question for Dan. So you had mentioned the guy that's in one of the observatories next to you that has the $50,000 F2 scope,
Yeah.
or something near there. So what Landon's doing and all the work that he went through, it makes sense for how he images, because he only has a small time frame to do it. But if someone is at a remote observatory where you have all night to go through, you don't have to do the setup, the tear down, you can automate. I can't, in my mind, how can you justify spending that much money for a scope or going fast like that? What does that buy him compared to you and your, what, F9, F10 setup?
I don't know. That's a hard question. The guy is also a retired optician. So this is like, I don't know. I guess if you were a car guy, it would be like buying the Lamborghini you always wanted or something. But so I think he's had numerous issues with numerous pieces of equipment, but I don't know why it's taken over a year for him and he's still not where it needs to be. I think
Well, yeah, but I was thinking at a much higher level. So if you're out there, so whether you take 2-minute subs at f2.8, or you take 5-minute subs at f5.6, if everything is so much easier, like Bill talked about, when you do the square or the cube, get down in the F numbers to do that, why not have a little slower optical train if you have the time, like you do at a permanent observatory, and you just do the imaging overnight, or like some of your images, you take some data and then you come back next year and get other parts of the data before you finish it.
That's a good question. I don't have a good answer for that, but let's compare it to the new guys that came into our building. Both have Takahashi refractors that are both fairly fast, f4 to 5 or something with the reducers. They run those dual, and they're collecting, they can theoretically collect 20 hours of data in one night, and at a third of the cost and a third of the hassle probably. And so it's a very good question. But then again, I'll tell you, this guy also has a plane wave 14 on the same mount too. So, so he's kind of got two different kinds of scopes there, but I don't know. There's a reason why I like my slower RC and things like that. It just, if it takes me 5 nights to get the same data that Landon gets in 2 hours, that.
But Landon does it here in Missouri with crappy skies, so he never gets the 2 nights. He never gets the 2 hours, versus you get in New Mexico the 5 nights all the time.
Yeah.
Yeah, but that was kind of my point. At a higher level, if you have a permanent observatory with, more decent nights, it just, in my mind, it for the complication, perspective of doing things, either you have time or money. It's hard to have both at the same time.
Well, Ryan, you mentioned a couple of different answers to your question there. One of my first thoughts was because he can. He's got the money, so he can.
Right.
The problem is when, as Bill mentioned, and as Landon is pointing out, the faster you go, the amount of work you have to put in goes up by the cube.
Yeah.
When Bill said, when the faster you go, the what was it, Bill? The cube is what on the collimation?
Aberrations.
Yeah. So, you get,
Yeah,
you
the
have to-
aberrations go up as the cube.
Yeah. So your work has to go up at the same kind of exponential effort, like Landon has just shown. So the guy that owns the $50,000 scope had either better have Landon available to do that for him, or he's going to have to learn from Landon how to put in that kind of effort. So that's one kind of question to answer there.
Yeah.
But you did mention though, Landon's here in Missouri where he can only use his scope half the time as opposed to New Mexico.
He wished half the time.
$50,000 F2 scope, you can get many, many more objects and many, many more nights. And if you have more clear nights than you have cloudy nights, if you're looking to generate data, go down, get faster, right, Dan? I mean,
Yeah.
take
Well,
advantage
I
of
guess
those
with
clear
that,
skies.
I guess with that, I think I'm, maybe kind of lazy, but
Yeah.
if I'm gonna spend a ton of money, the reason I'm spending the money is I want it to be easier.
Oh, well, and then someone like Landon wants better results,
Okay.
right? Because I'm with Dan.
Yep.
I'm with Dan. I mean, I'll stick at F30 where I don't have to do hardly any work on alignment.
I think there's two reasons why an F2 scope, I personally would feel a little concerned going that low, but F2 might make sense on a permanent scope. One of which is you're getting more light onto the camera in a shorter amount of time, so your exposure times can be shorter.
Absolutely.
Therefore, you can go a bit deeper if the sky is dark before camera noise starts to impact you. And as pixels get smaller and smaller, they're inherently a bit noisier. So
Right.
keeping those exposure times short maybe is a motivation. The other one I see online, although I don't completely understand it, is people talk about pixels per arc second of sky. And again, as cameras have more and more pixels, and particularly smaller pixels, then you can use a faster scope and sort of see more of the sky, but with the same resolution as with a slower scope. I'm kind of just parroting something I read. I don't necessarily understand it.
Well, Bill, you're exactly right. And I was waiting for you to be able to articulate that for Ryan. And my thoughts were at some point we reach a point of diminishing returns, and that there's two significant points there. There's the personal point where Dan and I are the same. We don't want to put in all the effort. So, Dan and I reached the point of diminishing returns at F20. Anything faster and we're kind of like out of here. But, but then you have the diminishing returns of how much effort and how much money do you put into something to find out that you're not getting really much of an increase. Now, you take a scope from 10 years ago. Yeah. You can improve that by a long shot. But when you start talking F2 versus F3, have you reached that point of diminishing returns where it's just going to take you forever to get that thing to work? And then you get a 5-minute extra, you get a 5-minute faster exposure time. That's this whole curve, this envelope that has to be figured out. And that's a personal choice.
Yep. So I know I've talked to a couple of the guys on here. I'm not sure if everybody knows, but I bought 25 acres in Missouri in a dark sky area or darker sky area. So I closed on it last month. I'm still doing some things, getting the land ready, but hopefully here in the next couple months, I'll have the gravel brought in, have a parking lot made and area for doing some observing and imaging, and would like to invite everybody down.
Too bad we got COVID.
Where are you?
Yeah, that's. Where is it?
So it's a couple miles away from Richwoods, Missouri. So about 22 miles south of St. Clair.
How'd you find that?
I've been looking for several years, and I ran across it on Realtor.com.
Huh,
That's a
so
good
close
area.
to-
I've set up down there a few times in past prior years. It's a nice dark area.
Yeah,
That's off of 44.
about 22, 23 miles south of
Oh.
44. It's off of Highway 47. The driveway's a half mile long to my property off the highway.
Cool. That's close to Buford Mountain.
It's closer, but it's just north of Potosi, right? Between
Yeah.
Sullivan, yeah.
Yeah.
Yeah, that's a good area. It's kind of this dark area between Interstate 44 and 55.
Yeah, it's so from my office in Chesterfield, it's a hour drive. So it's the darkest place that you can get to, hour drive.
Well, it's darker than Danville because Danville's an hour from Hazelwood.
Well, so I went out there and I brought my light pollution sensor with me. And it's kind of one of the things when I went out and inspected the property before I made an offer, I told the realtor, I was like, okay, here's the check for the earnest money. But it's not valid until I come back later tonight when it's dark. And so the SQM readings were very similar to Danville. And it's similar in Danville in another way, where in Danville, you've got the light dome to the east, with where this is, the light dome is to the northeast. So it's still fairly dark to the east. The south and the southwest are the darkest parts of the sky. But I could see the Milky Way naked eye, just standing in the middle of the property.
What kind of horizon obstructions do you have?
So all around, looking around, like I said, I've got 25 acres. I've got a 6 or 7 acre field, which is where I'm thinking about setting stuff up for being able to observe and possibly doing an observatory in the future. There is a higher point. So there's a fifth wheel camper trailer that's on the property that's in pretty decent shape. So, place for a warm room. But up there on the ridge, I'd have to cut down, several trees to get down, low to the south, which I obviously, north, east, and west don't matter as much. It's more the south view that you want, because the other things you can image, at any other time of the year.
That sounds great, Ryan. Maybe a future meeting, you could show us a few photos and what you're thinking. That'd be cool. And if you need any help, anything at all, anytime, day or night, just call Don Fick and he's fine to come out there and help you cut those trees down.
Yeah,
Okay.
thanks, guys,
Right now I'm tractor shopping, so I've got some things I want to do, but yeah, I think it'll be nice, but if everybody else would quit buying equipment, maybe we would. I guess I really don't care about cloudless nights. I just want some decent weather so I can do some more work at the property.
Oh yeah, I didn't think about that. All of these people buying equipment and getting it delivered. You're right. It doesn't extend cloudless nights. It just stacks it up to the point where we get 6 feet of snow.
Right.
Man, an awful lot of equipment being bought now.
But Yeah, I mean, I've got, like some maps of the, with the property lines on, the Google Earth view. Some of those. Hey, Dan, you just want me to post like a picture of the property lines superimposed over the Google Earth view?
Sure, you can do that.
Yeah,
Okay.
that'd be cool.
Yeah, I'll post that up to the ASEM group. Even though it's not an actual sky image, it's going to be the opposite, looking down.
Well, the Digital Astro group. You post it to the riffraff over at the ASEM group, and you're gonna have hordes descending on your place.
You'll have people like me coming down. Yeah, you gotta watch out. Hey, I have about a 5-minute kind of topic I'd like to share if it fits, if we have time.
Sure.
We got all night, don't we?
Let's see if I can share this.
Good job, Landon, by the way.
Yeah, that was great, Landon.
Thank you,
Thanks for
buddy.
doing that.
Yeah, very interesting then, Landon.
This is, I don't know if you can see this, but I was really intrigued by something Mike Kay had presented on his solar scope and his topic, this discussion of banding that occurs with solar scopes. And I was listening to a professor from Missouri S&T talk about filters and etalons. And as the bandwidth got narrower and narrower, he talked about how the partial coherence of light caused banding. And as he laid it out, I realized, oh, I think that's exactly what we see. So I've kind of dumbed this down to a point I can almost understand it. And I thought I'd just quickly throw it out. And you guys can obviously explore more if you care about it. But the idea here is that you have a solar scope, and in here is an etalon that's filtering the light down to a very narrow bandwidth. And by very narrow, the specs on this one are a 0.6 angstrom bandwidth.
What's the matter?
That's really narrow. And the images that people show, I got this off Cloudy Nights, but I think Mike was showing a similar effect. Not his weren't quite so many, but this idea of these light and dark bands across an
That
image.
looks very similar to what I see. Yeah.
Yeah. So what this professor was explaining, that if you have incoherent light, so you've got all these atoms with electrons around them, and these electrons get excited and then they collapse back down to their ground state and they emit a photon, that these are all done randomly. So different atoms and different electrons are emitting trains of light at different times and of different durations and in different directions. But a telescope has the effect of aligning all those directions into one train, like in the upper view. And then a filter has the effect of filtering out those that have about the same train width. And in an extreme case, like a laser, all the peaks and valleys all line up and they're going in the same direction. That's full coherence. Partial coherence is kind of somewhere in between, where you've got more and more of the photons lining up and in phase and in the same direction as you filter things down in a telescope. And what he was kind of showing is, as you go through an etalon, that this coherence goes up as the wavelength squared divided by the bandwidth. That once you start getting to where this coherent length is on the order of the size of the etalon, you're going to get banding, was the point he was making. I'm really simplifying this because I didn't understand the whole discussion, but you get the concept here, is that if you're using a really wide bandwidth filter, say like an RGB blue filter or something, they have a really wide bandwidth. So the coherence length is maybe 40 microns, which is much smaller than the filter. So you're not going to get interference off the front and back of the filter, those reflections. And even when you go down, I think my narrowest band filter is a 2 nanometer filter. So that's 2 millimeters, but my filter is 3 millimeters thick, so I'm not going to see much fringing in that situation. But you get down to an etalon of 6 angstroms, and that's about 72 millimeters, or almost 3 inches. So that's thicker than the width of the etalon. In other words, the light that's hitting the front of the etalon and the light that's hitting the back of the etalon and the reflections that are going through the etalon are in phase with each other. They're coherent, or at least partially coherent, and they're going to introduce interference fringes. So that was the point he was kind of making, and that kind of was an aha moment with me about why Mike is seeing these fringes that don't really seem to go away. And then then the questions was, well, that's great, but what do you do about it? Well, there's not a lot you can do. What apparently some people do is vibrate these mirrors so that they're maybe slightly rotating to average out or blur out the fringes. Another approach is vibrating the camera. I don't know if that's really practical in a solar scope or not, but apparently that's some of the typical ways you get rid of it is rotating the mirrors a little bit to kind of blur out the banding. But anyway, that was just my kind of aha moment from Mike's presentation and listening to this professor.
Hey, Bill, this is fantastic. Can I ask a couple questions?
Sure.
I'm just curious because you're an optics guy and I'm not. I see the banding get worse when I use a Barlow. Does that jive with what you're explaining here?
Yes, because what this professor was explaining is as that F number goes up, or as you're putting in a Barlow, you're narrowing the directional coherence. You're in other words, you're collecting more and more of the light that's going in a specific direction down the middle of the tube. You're limiting your field of view, so you're looking at light that's coming more straight down the tube, and you're filtering the wavelengths. So it's directionally coherent and temporally coherent. If you use a low F number, then you've got rays of light coming in from the edge of the aperture or the center of the aperture. They're traveling in a little bit different direction. So yes, he would have said that increasing the F number or putting a Barlow in would make the problem worse.
Wow. And then my other question is, coherence is a new term for me. I'm definitely going to do some research on that. Is that similar to polarization?
No, they're distinct.
Okay.
But Wikipedia has the nice article on coherence and partial coherence. Yeah, so polarization's different. So polarization has to do with the direction that the electric field is oscillating, whether it's up and down, left or right, or some other angle. Whereas this is referring more to the direction of travel of the light ray, and it's hard to describe. It's hard to describe this effect a little bit, but as atoms release a photon, it's not like they release a continuous stream of light. They release a stream that's a certain time phase long. There's a certain number of peaks and valleys in that crest, and that determines its bandwidth. As you filter it, you're selecting out those photons that are more and more meeting a certain criteria, and essentially you're throwing out all the light except for those that are more and more coherent, and therefore you get this interference effect.
This is really fantastic. If for no other reason, I've always felt like I've been doing something wrong because I've read a lot of articles about people doing camera tilt and stuff, and I can't get rid of this banding other than by doing flats. So
Thank you, Mike. Thank you, Bill. Bill, you want to go back to that image of the sun? Okay, so yeah, exactly. When I've got an H alpha scope and I've got quartz, and I've never saw that visually. But when I first put a camera on, those things stood out like a sore thumb. And I did a little research and I found out, I could buy a tilt, a little mechanism that would allow me to put a tilt. They call them Newton's rings. Is that right, Bill?
Well, Newton's rings are essentially a circular ring pattern. It's a little bit different, but that's a good point, Grant. Another trick the professor described.
Well,
of getting
hold on a
rid
second.
of-
Hold on a second.
Yep.
I want you to follow up as soon as I finish the thing. The images I was getting looked exactly without having Mercury there. They were exactly like that. They weren't complete circles. They were larger radius circles. But as soon as I got that tilt device that let me put a little tilt in it, man, they went away. But when I put a Barlow in there, they came back. They weren't spaced as close as this. They were spaced further apart.
Yep.
But I had to get in there and I had to tweak that filter device, and it was really very sensitive. You could see them come and you could see them go. But I was able to tweak it and got them out of my 3X Barlow. So that begs the question, what you're saying, what your professor's talking about, is that something completely different than what we're getting, than what we're seeing that is removed by the tilt device?
No, he would say that's the same thing. In fact, that's a trick Mark Jones taught me many years ago when we worked in an optics lab. Is if you put a wedge in, what's really happening is you're trying to make the rings so that they overlap each other so much they just get smeared across each other. Or sometimes you can make the wedge so that one side of the wedge is thicker than the other side of the wedge by the amount of this partial coherence length, and therefore it just blurs everything out. So you might argue it doesn't get rid of the rings, it just makes them so close together that they just blur out, and they no longer have there's a technical term, it turns out, called visibility, this contrast of the fringes. It's a common trick to put a wedge in to try to blur those fringes out. So I'm not surprised that put it in there, it went away, but then you put the Barlow in and it kind of had the opposite effect of spatially making things a little bit more coherent again. I'm just guessing there.
Well, here's the thing that Mike needs to come in here. I need to ask Mike a question with you listening, Bill. You there, Mike?
Yeah, I'm on. Yeah.
Okay. So when I get the fringing bands, I get that with a cork. What are you using, Mike, where you're getting the fringing bands? Or those bands?
Well, I'm using a double stacked lunt, but
okay,
I do have a similar experience with you, Grant, that visually I can't see it, and it's only when I use the camera that I can, which is always why I've thought maybe it's like some sort of like interference with a like filter over the sensor or something like that. And I have tried these tilt devices and they've helped, but it doesn't go away.
Right. So here's what I'm using. I'm using a cork, and the tilt device goes in front of the H alpha components. Whereas, Mike, you're using a tilt device at the eyepiece side, right?
Yeah, it's right. It's tilting the camera. That's
yeah. Oh, it's tilting the camera after the H alpha filter. It's tilting the camera between the H alpha filter and the camera, right?
No, it's after all the.
That's what I mean. That's what I mean. You come in the lunt, you go through all the H alpha filters, then you come out the back where you normally have an eyepiece or a diagonal.
Right.
And you put the tilt device there, then you plug in your eyepiece and your diagonal.
Yes.
Right. So the tilt device is between your eyepiece and the H alpha elements, whereas when I'm using the cork, the tilt device is in front. It's between the sun and the H alpha components.
Yeah, okay, that is different than my configuration for sure.
And I mean, they're there and you can see them disappear with every little tweak until they are completely gone. Now, Bill, so you visualize the two different configurations between Mike and me, right?
Yeah. Yes.
So
a bunch of stuff going on there. I mean, with that wedge, if you look at the bands in this image, you make a good point that they have a radius to them. And if you can move that center of radius right into the center of the camera.
That's it. That's exact. Thank you.
then you get exactly what you said earlier. Those are Newton rings. That is exactly what Newton rings are.
I couldn't remember it from the research I was doing, and you just exactly right. You said that's where they said is you've got to get that centered, and they're Newton rings. Is that different than what your professor's talking about?
I don't think so. I think they're the same. I think they're related. You're kind of beyond my knowledge here. They're a little bit, but you guys both make another good point, which is once you have this coherence, it not only affects the etalon, it affects every other element in the train that's shorter than that coherence length. So in other words, the window over the filter can also have bands in it.
The window over
Over the sensor window.
okay.
The camera sensor, it'll have a glass protective plate, which are incidentally often intentionally wedged, more to prevent ghost images than anything. But they will also produce this ring pattern in the presence of coherent light.
Well, and when I rotate the camera, the bands rotate. So it is, for me, it is something
So
related.
it's in the telescope. Yeah.
And it is not, I can
It's in the
have
sensor.
some, like, it is different than Newton's rings, though. I can have both interference patterns present.
Huh.
But the Newton rings are, I am able to get rid of those with tilt very easily.
Okay. Yeah. So there's two effects there. There's interference probably in the etalon, and there's interference maybe coming from the camera sensor window. Not sure.
Huh. Oh, and what kind of camera are you using, Mike?
It's a ASI 174. I think you have the same, Grant.
Yeah, I got something close. Yeah. Well, it's not a DSLR, is what you're not using.
Right. Yeah. It's a monochrome CMOS.
Yeah, I'm using a monochrome too. Yeah, exactly. And then I've got, I think I've got a clear window in there, which I got from ZWO. Okay. Thank you, Bill.
Sure.
Looks like I got lucky.
Yeah, I got some Wikipedia reading ahead of me now, Bill. Thank you very much.
Hey, Mike, you might want to think about selling your lunt and getting a quark.
Someday. Not until after the next solar cycle.
Oh, you mean, well, before it starts. Well, yeah. I'm looking forward to it because I didn't have this H alpha equipment when we had the last solar maximum.
Yeah, me neither.
Anybody have anything else?
So I'm trying to share a map of the property, but I've never done it on my cell phone before. Can you guys see it?
Nope.
Okay, hold on.
You're not sharing your camera.
Okay. Yeah,
There
there
you
we
go.
can see it.
Okay.
How do I zoom with Zoom?
So on my phone, I can just pinch and drag.
Oh,
Does
yeah,
that
that's
make
better.
it-
There you go.
Okay.
Not real sure what I'm seeing. Are those clear? Are the gray areas kind of clear and the rest wooded?
Yeah. So over here, well, I guess if I kind of zoom in, so that's Highway 47 up there in the upper left corner. And then the yellow lines are the
yeah.
property lines. And then when I did this on Google Earth, I got the longitude and latitude grid turned on.
Boy, you got a nice field there.
Yeah. So
Really
with
nice.
that, it was cleared off probably about 10 years ago. It's starting to grow up. I started cutting things down with a chainsaw, but it's going to be way too much work. A friend of a friend has a bulldozer, and so a couple $100, he's going to bulldoze the field for me and get rid of all the trees. So it'll be all completely clear.
You know, I tell you what, that looks like your property line makes it look like a triangle.
It is.
You know, you've got all sorts of opportunities to freak out the satellite imagery by putting in some big crop circle kind of things. You know? It's like I can see right now that looks like the A12. Anybody remember the A12?
Yeah.
Yeah.
Wow, that's really nice. So what's that building?
So that is kind of like a prefab garage shed.
Oh, good.
And then if you kind of follow it down right here, it's got a fifth wheel camper trailer there with
Yeah.
a deck built in on it and stuff.
So right approximately where you think you're going to put your observing field?
So I'm thinking right here in this 6-acre field, probably right up around in the corner where can you guys see when I'm zooming in and zooming out?
Yeah, we can.
Oh, yeah. So kind of where the 38 is, kind of in the square right in this area, is where I'm going to have some gravel brought in. And it's why I'm, shopping for a tractor. Once I get it bulldozed down, all the trees and shrubs out, make a parking area. And then like right now, if you come and look, the driveway that comes down and then it's, Highway 47 is all the way up here, but the highway or the driveway is a half-mile long. So I need to touch up some on the driveway. And then I want to make a driveway path all the way around the outside edge of this field with new stone brought in. So that way you don't, if it's wet, you don't have to have a 4-wheel drive to get back there.
Yeah, that's nice. Another benefit of that, I don't know how you feel about this, but it's kind of nice to burn those fields, promotes wildflowers, native grasses and stuff, which is kind of cool, but also, it's the trees from coming back.
Yeah.
The gravel will keep it contained.
I'm not going to gravel the whole field.
No, I just mean the perimeter.
Yeah.
Yeah.
Okay.
It's like a fire break.
Yeah. And then, and I think I forgot to mention the other nice benefit is I'm a couple miles from, I call it a village, or I guess it's a town, Richwoods, Missouri. I don't even think they have a stop sign in the whole town. But anyway, they've got an AT&T cell tower there that the property's kind of up on a high point. I can see the cell tower. And so with my AT&T phone, 45 megabits up and down.
Yeah, Richwoods is kind of the Paris of Houston County, or no, I'm just kidding. I was going to ask you a question. Oh, do you have electricity on site?
Yeah, I've got 200 amp electricity. I've got a well and septic.
Wow.
Buford Mountain North.
Yeah, this is great.
Yeah, there you go. But yeah, it's
all better than Danville.
That's exciting. Congratulations on that.
No, thank you. Yeah, I'm just looking forward to people quit buying equipment so we can get some nice weather and we can all come out and enjoy it.
Even at 8 degrees above zero? Oh,
it's better than 4 below that it was this morning.
Yeah, it was crystal clear last night, but man, were the stars moving around the sky. They were twinkling their little stars off. It was,
I noticed that. Clear. Really turbulent.
So, yeah, can't win for losing there. Yeah, Bill, so you noticed that. So, Dan, did you go outside and do a lookup?
No, for the imagers, I mean, with the snow on the ground, it's not worth even thinking about setting up the telescope because it's so bright from the city. The light reflects off the snow.
Okay.
It's just terrible.
So what happens when you get the kind of just manic motion seeing wise like we have on cold nights like last night, where all stars are just this fuzzball that's just shaking and shimmering, and What does that wind up looking like on some of your images, or do you?
Yeah, a night like that, I can't use my big scope. We've been getting a lot of those down in New Mexico. The smaller scopes don't show, they don't have the resolution to show it, but my scope, there's a lot of nights even down there where we have clear skies, and it's not worth me taking pictures because the stars can literally be 2 to 3 times the size.
So you get bloated stars is basically the effect that you see.
Right. Yeah.
So you've done a bang up job on focusing, and all of a sudden you get that turbulence and your stars come out looking like, God, I thought I focused this.
Yeah, even down there with the good skies, I can see that kind of stuff come and go. You can have one exposure that looks really good. The next one, the stars are twice the size, and then the next one they're back to normal.
Okay.
I never, to be honest with you, I never got anything out of my driveway here that I would have kept. So the skies are much better down there, but we still have those same nights. Or if the jet streams overhead, I know it's not worth me imaging and things like that.
Right. Okay. Yeah. Okay. Hey, so Ryan,
Yeah.
it sounds like this is the time to buy all the equipment we want.
Yeah. Well, it at least for the next month or so. Like I said, I've got some work to do.
Yeah. And if you're like Landon, there's plenty of work to do while the seeing's not worth a darn.
Right. But now with the I don't care if we have cloudy nights. It's just the foot of snow I have down there right now is the problem.
Oh, I got you. Well, that's right, because it's cumulative. There are too many people buying astrophotography stuff then, huh?
Right.
That's right. I made the comment about getting 6 feet of snow, didn't I? Oh, we're gonna get some more tonight, right? Is it snowing out there yet?
Then it'll get warm and it'll melt, and you won't be able to get back in, and it's just kind
and then, humidity will shoot up, and that just talks frost. And I knew I started picking up plastic models for a reason.
I actually, one of the guys is moving out of a big observatory down there, and I bought his seeing monitors. He actually had 2 of them. And so I'm going to be able to quantify some of the seeing fairly soon, and I'll have an extra. More or less what these things are is they're like a camera that points at Polaris and takes 100 or 1,000 exposures and quantifies basically how good the seeing is in arc seconds, and it does that all night long.
Okay.
So I'm hoping to somehow soon start getting some of that data, and like I said, I'll probably have an extra one that we might be able to run somewhere.
All right. So with that, if you'd be open to it, I've got internet connectivity down there, so I bought a cellular hotspot, and so I've got that set up in the camper. If you wanted to do some testing with that and come down, we could mount it someplace close to the camper, and we can see what the scene looks like and get some data points and compare that to New Mexico if you want.
Yeah, we could do that. I won't have a use for the other ones, so it doesn't really matter to me. It's just I'm not sure when I'm going to get down to get them. But yeah, definitely something that would be interesting.
What are they capable of doing a sky quality at the same time? I mean, aside from seeing about a transparency, what the sky meter does.
No, that's a
separate thing.
Yeah.
Well, then maybe I might pitch in a sky quality meter, and Ryan can use his considerable networking skills, and we can have a website where we can check sky quality and seeing.
Yeah, that's kind of my goal. We've got some of that down in New Mexico, but we don't have all the pieces, and we're starting to try to collect them and get them all going again.
Dan sent me a link to a weather station that I kind of looked at it. It looks pretty good. That's another thing on my bucket list is probably pick up one of those. And then, so I'm going to be interested. I mean, if you guys happen to see a good deal on like a used all sky camera, something like that, would be something. It's I kind of think about this as kind of the board a month plan. Just keep
Sure.
adding stuff as time goes on, and then eventually would like to put a building out there and possibly be able to have a couple scopes there, and we would be able to do some remote imaging from here. While obviously New Mexico has more darker nights, less clouds, less humidity, things like that, but the benefit of this was kind of like before, we had a group of us that went down and, set up at New Mexico. A couple of us are still there, but some others have dropped off because we weren't happy with the management of the people at Dark Sky, New Mexico. But the nice thing about this is, it's not a 2-day drive.
You're an hour away.
Right.
Yes, sir. Well,
So-
we're talking about sky quality meters and all that. We just happen to have a member present as we speak, whose main focus is on sky quality. Mr. Don Ficken, are you paying attention?
Yeah, I am actually. Thanks. Yep, we've got 17 monitors around the state.
Have you got anything down by St. Clair?
Not exactly, no. We're moving them around a little bit, though. We are moving them a bit from location to location.
Okay. And this is still, you got to go out and dump the data out of each meter. It's still not connected on the internet, is it?
They're capable of being connected because we're moving them around right now. And frankly, some of the spots are not necessarily that sophisticated. For example, to do an internet connection is sometimes a troublesome thing for some of the groups. And also even sometimes getting electricity is a challenge.
Okay.
So it depends a little bit, but yeah, we're working on it. We're got a big program we're launching at the end of the year that might make some use of these and some handhelds too.
Okay. So I have my own handheld, which is what I used before I actually, put the bid in on the property. But I didn't buy the one that you can connect up to the network. So with that, if you are looking for a place to put one that has electricity and connection to the internet, I'd be more than willing to let you guys put one there.
Yeah, we may talk about it. What we're mostly trying to do is we're trying to encourage a particular site to do a dark sky site. In other words, so that's kind of what we're using them for right now. It's really a funded program. The one thing about the meters is that it is nice to have internet connection, but they will accumulate and store the data for months.
Sure.
So I'm literally taking 1 month readings at a time. It'll have every 5 minutes. So they're I mean, you can pretty much remotely set them up, but yeah, it might be an interesting possibility, at least for a period of time. We'll see.
Yep. Okay.
Thanks, Don.
Oh,
What you got next month, Dan?
I don't have anything yet.
Well, I guess I'll do an extended astrosurface thing then.
Okay.
I fired it up tonight just before, and it's like I got a really slow computer or internet or both. So I figured I was going to kind of skip past letting it do a process and just pull up one that was processed earlier. But yeah, I can do something next month.
Okay, that'd be great. I'll see if Duchek is ready to do something on that one he wanted to talk about too.
Hey, and I thought I heard someone mention that there's another program out that you would like to see evaluated. Which, you remember which one that was? It was another freeware kind of.
Oh, as far as paint programs at Affinity Photo,
Okay.
it's been around for a long time. It's fairly inexpensive. I think it usually sells for about $50. And their newest version has some astronomy imaging things built in. It will read FITS files, it will stack them, it will do some things like that.
Okay. Did you say 50 as in 50 or 15 as in 15?
50 as in 50.
Okay.
And it's also one of those programs that's always on sale. So you can usually get it for $25, and it's good until the next major version upgrade. And I don't watch it enough, so I don't know how long it's been good for, but they've been on 1.X's for a long, long time.
Hey, Dan, do you know anything about this new ASI 2600 camera?
Yeah, I mean, that's what Landon was using for his imaging.
Before you went to the 62, you mean?
Yeah, his 62 is the brand new one he just got, but he had a 2600, the
Yeah.
one-shot color. The 2600 is a good camera, and it's a good. It along with the 6200 are kind of based on the same chip family, and those are the latest and greatest and supposedly the best chips out there now for astronomy, as far as the CMOS ones go. The choice between the cameras tends to be, do I want the full frame of the 6200, or do I want the smaller APS whatever size of the 2600? So
Opcore seems to be saying this is a new version of the AES 2600.
yeah, there's a new monochrome version coming out. They've had the one-shot color for a long time, but the monochrome is just now coming out.
So it's the monochrome that's new.
Yeah, and QHY has a monochrome of it too. They have pretty much the same deal. But yeah, the new one's the monochrome version of it. But they're both very similar. Just one's got the large more real estate, but with more real estate, it requires a much better telescope to get to illuminate it.
Yep.
And everything around it's more expensive. And there's a lot of people like me that are still using old CCD cameras that, my next upgrade will probably be a 2600, just because I don't want to spend a lot of money on filters.
Right.
The big one requires big 50 millimeter filters probably.
Yeah, it seems like this is an odd size for the filters for that particular one, the 2600, isn't it?
Yeah, the 2600 you can probably get away with. You can get away with 2-inch filters, or maybe even, like me, I've got 36 millimeter filters right now, and those would probably work for my slower scopes.
I was thinking somebody I saw in Cloudy Night said this took a particular size filter for this particular, it was 36 millimeter.
Yeah, 36 millimeters would definitely work fine for it. The next step up is, I guess, the 2-inch ones.
Will the 2-inch work with it?
Say it again.
So will the 2-inch work with that particular camera?
Yeah, I believe so.
Okay. Well, I was thinking somewhere I saw, and I can't say that I got it correctly, is that somebody was complaining they had just purchased 2-inch filters and that they had to get the 36 millimeter that they'd asked, I guess, CWO about it. They said they needed to get the 36. Now, maybe that was because it was a better match or something. I don't know, but I was thinking that there was a problem. And I frankly didn't pay that much attention, but it just kind of rung in my head just to make note of that,
My math mode is 2-inch. How many millimeters is 2 inches?
I don't know.
I thought the 36s were smaller. I remember seeing that.
I think that's right. That's what I'm thinking too, because that's what I was remembering. It's like, wow, I thought just a 2-inch would work on it, but and I could be completely wrong.
No, I remember that exact question. I think the guy's issue had something to do with his filter wheel or something. They just didn't fit right in it or something.
Oh,
I think it was more of that kind of issue versus camera.
Okay, got it. Yeah. Okay, that's fine.
But yeah, those are really good cameras. Those newer chips are really good. It just, these newer cameras have all these megapixels, and you're talking really big images.
Yeah, yeah.
I think those images out of Landon's camera, I could be wrong, but DeBaird, I think they're over 250 megs apiece.
Jeez. Yeah, well.
I was thinking about it.
I'm still in the little bit get started phase right now for that.
Yeah, these two new guys that are in our observatory, they have two of those 6200 cameras.
Oh my
And I'm thinking running tandem, and they're generating 250 megs of data every 2 minutes or whatever, these short exposures. And then there's some guy that brought some scientific scope down there that they got some grant for that literally has, I think, 6 or 8 cameras on it. And I was thinking, boy, that guy's going to generate a gig of data every 60 seconds.
Yeah, you gotta have not only process, I mean, the storage, but also just to process that thing.
Storage and bandwidth to send that stuff. It's just, yeah, that's going to be my issue, because I use a lot of old equipment. You know,
Yeah.
I got stacks of old laptops, and they're just going to look at that and laugh.
Yeah. Yeah, I know
It's a never-ending battle. You buy it. Every time I think about that camera, I think, well, then I need a bigger scientific filter, and I need a focuser that handles a bigger image circle, and it's it's a never-ending task. And like Grant said, I'm kind of a lazy imager. I put my stuff together, it works. I want to get, if there's 10 hours of collecting data, I want to get 10 hours of data.
Yeah.
And I don't want to fiddle around with stuff.
That's smart though.
I didn't mean that in a derogatory way.
Oh no, I didn't take it. That's just the way I function. My stuff works, so I'm using 10-year-old software.
Yeah, I mean, if it ain't broke, don't fix it.
And you know what? I think it's back when I guess during World War II, the people could really fly well. They didn't need necessarily the best equipment because they were just really, really good. So if you get really, really good at what you're doing, you can really get some good images, whereas the guys that get the really expensive stuff may not really optimize it, really.
Exactly.
Well, and
Hey,
a lot
Mike,
of this,
before you leave, let me talk with you again.
with a lot of the stuff today, I think of these ASI cameras and stuff, they come out with a new version every 6 months, 9 months, 12 months. And they just, you never get a chance to really use them, it seems like to me.
Yeah.
And a lot
Well,
of the
if
equipment,
you're-
it's much cheaper. You know, I could buy 3 of those cameras for what the old one cost, or you could buy 2 or 3 of those Ioptron mounts for what mine costs, you know, and it's a hard call, you know, your next mount. Do you buy one of these expensive ones, or do you buy one of those and throw it away after 5 years and buy another one of it, or the next greatest one?
Yeah, that's
You
right.
know, it's always,
Well, the one I bought, I'm buying to last. So, you know, I
Yeah.
could handle up to 70 pounds. And of course, that would be the right poundage you put on it. But on the other hand, it should do okay.
Well, don't feel bad, Don. I mean,
Oh, I'm
Dan, we had the apparition of Mars was 2018, right?
yes.
Those cameras that I bought back before that are the ones I'm still using. So, I mean, I guess I'm like 4 generations behind, aren't I?
Hmm.
All right, guys, I'm gonna head out. It's just a good job, though. I think Landon did a nice job. I love what he's doing. Man, that's scary what he's doing, though. Wow, it's amazing.
Yeah, I think he's showing what, you know, there are a lot of people like me that used to be, for lack of a better term, you know, mono camera filter bigot type people, you know, and with these newer color cameras under somewhat darker skies, you can really get the same kind quality of images, if not better, these days. And, you know, he can go out there in 2 hours and get more than I get in a week.
Yeah, but you know what? Everybody's got their own objectives, and his is that he's working. He's got limited time to do things, and so he's building his program to fit that. Right?
Yeah.
I mean, that's
Right.
the thing, right? Whereas, yeah, you know, some of us can work a little bit more flexibly, I guess. So that's all right, though. That's good. All right, guys. Good night. I want to head out.
Hey, Mike.
Which
Wonder if
mic you
Mike's
try?
still there. Mike's not there. Oh, there he is.
Yeah.
Mike, let me. I got a mea culpa here. On your H alpha scope with your camera.
Oh, different mic.
Yep. Different mic.
I thought that was you. Oh,
No.
Krasny. No. Yeah. Okay.
Sorry.
Oh, good. I don't have to embarrass myself then. Okay.
Okay. Talk to you guys later.
All right. Have a good one.
Well,
Bye.
thanks, guys.
All
Yeah,
right.
thank you,
Thanks,
Dan.
everybody.
Thanks, Ryan. Hey, good job, man.
All right. Thanks, guys. Bye-bye.
Bye.
Bye.